Hello everyone, so we're going to go ahead and get started on the next section, the fundamental theorem of calculus. I'll be honest with you, I honestly didn't know if people told me, hey, what is the fundamental theorem of calculus? I would have just told them, I don't know, I've never heard of that before, I don't know what the actual rule is. But really, when I sat down and actually looked to see what the theorem was, it really is just a fancy way of saying, hey, let's calculate the definite integral using our definite rules. Which I know in a previous section I've already talked about definite integrals, but that was just using the calculator and understanding graphically what's going on if you're looking at trying to integrate a function from a lower bound to an upper bound. This is really just definite integrals. In the previous section, we were doing indefinite integrals, and we learned a few rules to go ahead and use the power rule. What happens if you have the integral of 1 over x and e to the x and so on and so forth. So this is just kind of building off of that, and in turn, hopefully this video will be shorter because of it. But essentially, we're going to be doing the exact same integral rules that we're used to, or that we're used to doing, especially from the previous homework. But we're going to actually figure out what is that, let's evaluate that integral from a lower bound and an upper bound. And it's just that it's very simple. All you got to do is integrate your function. Then at the end, plug in your upper bound, then subtract whatever. And then you get a value, and then whatever that value is, you're going to subtract it from plugging in the lower bound. That's it. It's really straightforward. So I'll do this first one with you guys. I'm only going to do a couple of these problems, and then have you guys on the next page kind of put together some old, tying in some old concepts and using tables. I think the AP exam, especially calculus over the years, they've really liked using tables and function notation to solve a lot of these problems. But I'm just going to go ahead and do a few examples here. I'll probably just start off with the simple number 1, all right, and just kind of show you exactly what is meant by this. So again, we're just going to integrate this like we normally would using the power rule. So if I did that, I add 1 to the exponent, so x cubed, then divided by that exponent, minus 3x, right? Now, different people have different notations for this. Some people use just a straight line with the lower bound and upper bound. I'm just going to go off of what my calculus professors did in college. So I'm just going to go ahead and just use some brackets and say from the lower bound to the upper bound. So this is the notation that I use to say, hey, this is the definite integral, or the fundamental theorem of calculus, right? So we integrated the function, and then we're just going to plug in our upper bound. So that's going to be 2 cubed is 8 over 3. And then we plug in 2 into that. That'll be 2 times 3 is 6, right? So again, we're plugging in 2 into our function. Then we're going to subtract that from plugging in 1. So this will be just 1/3 minus 3, right? And if I do that math, let's see. If I do that math, I'll end up with 7 over 3 and 7 over 3. Sorry about that, my phone just got turned off. Okay, so yeah, so we go ahead and do that subtraction. So this becomes over here, I'm just going to do some math on here on the bottom. That becomes 7 over 3. This is negative 6 plus 3 is minus 3, but I can just, write that as 9 over 3. So then this becomes negative 2 over 3 as the final answer. All right. So I'm trying to think. I'm going to go ahead and do, I guess I'll do the bottom two, just to kind of give you some variation. Most of this stuff I would want you guys to practice on your own. Actually, I can do this one right here. So I'll do one with a trig and one that'll involve a natural log. So with this one, I'm going to go ahead and integrate this. So the integral of that, I have to think about, so usually with integration and derivatives, sine and cosine are kind of what they convert to. So I know that I'm going to have the cosine of x, but if I remember, the derivative of cosine is negative sine. So that means I have to make this negative cosine for it to be positive sine when I take the derivative and go backwards. So that'll be plus x, and then I'm going to evaluate this from 0 to pi. And now I just plug it in. So when I plug in pi, I have negative cosine of pi plus pi minus, and then now I'm going to plug in 0. negative cosine of 0 plus 0. Okay, now to remember my unit circle, cosine of pi is negative 1 times negative is just positive 1 plus pi minus, and then cosine of 0, that's just 1, so that'll just be, 1, 0, 1, so that'll be negative 1 plus 0. So that'll just essentially be pi plus 2. Okay. And then we'll do, I'll do this one right here. So again, we're going to go ahead and, again, if we have multiple terms on the top and only one term on the bottom, I'm going to break up my fraction and I'm going to rewrite this as the integral from 1 to 4 of, let's see, 2x over x squared is just going to reduce down to 2 over x. And then 3 over x squared will just be 3 over x, 3 over x squared, but I'm going to write that instead as 3 to the x minus 2 power. That way it's easier to do the power rule for that. And again, if you ever have like 1 over x or just a single x on the bottom with a constant on the top, hopefully you'll recognize that that's just going to end up being natural log. So this is going to be equal to 2 natural log of x, okay, minus, and then if I add 1, that'll be x to the negative 1, divided by 1 will, end up making that negative, so I guess, right. So that'll be minus 3 over x, and then if I'm evaluating this from 1 to 4, I'm just going to plug it in. So that's going to be 2 natural log of 4, right? And I don't need the absolute value symbol anymore because 4, this is verified. 4 is positive, so we're good to go. So when I plug in 4, I'm going to go ahead and do that, minus 3 over 4, okay? And then minus, let's see, if I plug in 1, that'll be 2 natural log of 1 minus 3, okay? Natural log of 1 is 0, so I don't have to worry about that anymore. And then I'm just left with 2 natural log of 4. And then here I have minus 3/4, and then this will turn into a positive 3, but I might as well think of this as positive 12 over 4. So 12 over 4 minus 3 over 4 gives us 9 over 4. All right. So honestly, that's kind of it. I mean, I can sit here and work all of these out for you guys. However, I think practice makes perfect. So I'm going to keep this video nice and short and allow you guys to practice this. And kind of like I promised before, I think instead of scanning my notes like I used to do, I'm just going to have you guys pause the video and look at the answer. So again, start practicing now. And then if you want, so pause the video and then unpause it in the next few seconds. And here are the answers. So don't spoil it. All right. So there's for the first two problems. If you want to pause it, you can pause it now to kind of like see what's going on. Then I'm going to go to the next 4 problems, and here we go. If you want to pause it, go for it. And then here are the rest of the problems. Okay. And then, of course, I have these problems on the back. So, I mean, again, really what you just need to understand is that, if I take the integral of this is just, integral of a derivative is just that original function. So it's going to be the original function from negative 3 to 1. And then you could just plug in your values, f of 1 minus f of negative 3. And then, read your table from there. F of 1 is negative 2 minus negative 3 is 4, so that's negative 6, right? And that's kind of how you're pretty much going to answer a lot of these questions. I even threw in some linear approximation in there just to kind of tie in some old concepts. But again, pause the video if you want to try these, to try these problems on your own. That's what I recommend. And then here are the answers. So I already worked out the first one. That was negative 6. Here's the next few. And then here's pretty much some problems, not necessarily integrals, but a good review of what we did before. Might as well practice it. Okay. And there you go. You can pause the video wherever you feel necessary. So there you go. That's the video. And I want to keep it nice and short because we have a lot of topics ahead of us for integration and a lot of very advanced integration techniques. I know tomorrow is going to be U substitution. And that's going to be the first step to take to doing some high-level integrals. All right, if you have any questions, let me know. Take care. Bye-bye.